Good
Okay.
morning, everybody. My name is Brian Rosillo, and I am the regional sales manager for Panasonic. And thank you very much for joining our session today. I think you'll be pleased with the presentation and the presenters that are going to present on our autonomous vehicle solutions. First of all, I'd like to review the agenda and also just kind of talk to you a little bit about what you're going to be seeing during this presentation. Um, the, the very the very first thing we're going to go ahead, Jeff Katz is going to go ahead and introduce our relay photomos and some of our wire harness options, along with our 5G connectors and our switches and our PIR sensor. And then Eric Johnsrud is going to cover our grid eye sensor with Jerry Machado right behind him, covering some of our passive film caps, inductors, and hybrid capacitors. And then closing out will be Matt Rose, closing out with our wireless options. And then Nick is going to talk about our time of flight camera sensors. The reason we've picked a lot of these products, between the Panasonic marketing product and Mel Foster team, is because we're seeing an increase in demand in these types of autonomous solutions, along with electrification and battery management systems. And what you're going to see within, what you see here on the agenda is you're going to see a lot of topics and conversations that we see a lot of interest from customers, just like you, that are moving into and switching into a different technology. One of the things is, as each presenter is going to go ahead and introduce themselves at the beginning of each presentation. I certainly offer you the option to put any questions you have during the presentations into the chat, and we will answer all questions in the chat either at the end of the session, and or aside from the chat feature, there will also be a live Q&A session at the end of the presentation, and each individual product person will be able to field and answer your questions. I also, I urge you to take any notes that you like, and certainly, if you want to have a follow-up or a more in-depth conversation, I certainly urge you to reach out to the Mel Foster team, and and they can get on the phone or do a WebEx or even a personal conversation if you'd like to know a little bit more about the specific components that are being addressed during this session. If you have any questions, again, please go ahead and put them in the chat, and or we will have a live Q&A session at the end. And then what I'm going to do is I'm going to go ahead and switch this over and let Jeff Katz kick this off and introduce himself and the relays and photomos options. So Jeff, if you don't mind, you can go ahead and start.
Hi, my name is Jeff Katz, and I will be going over several of our products, including the relays, our switches, our connectors, and our PIR sensor. So first, I just kind of wanted to go over the type of mechanical and solid-state relays that we have available for autonomous guided vehicles. And there's a number of functions that relays can serve within the autonomous guided vehicle or autonomous robotic controls. And the first one of those would be controlling the actual motor. Another one would be for charging and discharging of the battery. And also for safety circuits, potentially, such as emergency braking and LiDAR sensors as well, could be controlled by relays. And we also have solid-state options as well for battery insulation deterioration and for battery monitoring as well. So here you can see kind of a schematic where we do offer different types of relays for pre-charging, such as our EP series, which are completely sealed hermetically with hydrogen gas filled. And the purpose of that is to be able to switch high voltage DC without the electrical arc destroying the contacts of the relay. And we're able to get that into a really small size. And basically, the pre-charge would be used to discharge any kind of capacitance in the vehicle before charging the main battery. And then we have several different relays for the actual main charging as well. Also on the control board, we do have options for power photomos, particularly for electronic magnetic brakes of the motor. We do have various safety relays and signal relays as well, for that matter. Here's an example circuit of where we've seen one of our relays controlling the main battery and also for the motor control as well. So a lot of traditional designs have been using solid state IGBT for the switching. However, we've noticed that in a lot of these cases, sometimes the vehicle would actually catch on fire. And so a lot of these designs have been moving towards a mechanical relay solution. And we've seen our HE-S relay, which I'll go into a little bit more detail in, being used for this type of application to give it some galvanic isolation. And then we also do see our relays being used in both wired and wireless charging power supply configurations. So that would be on the charger itself, as well as on the autonomous guided vehicle. One thing I did want to point out is a lot of the relays that we have for mechanical side are AC relays. However, although they do not have the DC ratings on the actual data sheet, we do have a lot of reference test data we can provide showing the DC ratings. So for example, our HES relay can handle 35 amps at 75 volts DC, or it can handle 10 amps at 110 volts DC, even though it's rated for 277 volts AC. And that's just one example. So I just want to go into a little bit more detail about the HES relay. So what's interesting about this one is the contact arrangement. It actually has two normally open contacts as well as a normally closed auxiliary contact. And the purpose of that auxiliary contact is that you can monitor the normally open contacts for welding and design a safety circuit around it. Also, this relay features a very low coil holding voltage as well, so it doesn't use up a whole lot of power. Once the relay is energized, you can reduce the coil voltage so that it's only using up 170 milliwatts power. Here's another type of relay that we are also recommending for autonomous guided vehicles, and this is a slim type safety relay. And these use mechanically linked contacts, similar to the previous slide where it's got several normally open contacts as well as normally closed contact configurations that are linked together. So if you do have any kind of welding, this would be able to very quickly detect without any additional circuitry if you have any welding going on. And so this is a nice, very small, slim type size, as well as very low power consumption, down to 170 milliwatts holding power. I also wanted to quickly mention that we do have solid state solutions. We have what we call photomos, and basically these use MOSFETs as the output. So we actually have two MOSFETs per channel. The way that these operate on the input side is an LED, so it's current driven. Once the once the LED charges up, there's actually a photocell inside that converts the light into a voltage. It then is used to charge the two MOSFETs. Once it reaches the gate threshold, then the MOSFETs become conductive and turns on the load. And the advantage to going to this type of technology rather than mechanical relay, one is for the long life, so you're going to have a theoretically infinite life. You can get a much smaller size relay without the moving contacts, very highly reliable, very good against shock and vibration. So if your vehicle is possibly going to have any shock and vibration, this relay is very resistant to that, and there's also no mechanical sound. So a lot of what we've seen this type of relay being used for is in the battery monitoring and also battery insulation detection. So our photomos have a range up to 10 amps and also up to 2000 volts. At the 10 amp range, it's more for low voltage and DC type applications. And then on the 2000 volts type applications, it's usually very small size current loads. So one example here would be for battery monitoring for the actual cells. So the way that this is done is you would have the battery cell side that you would turn on to charge a capacitor, and you would use the photomos as isolation for charging up that capacitor. And then you would have a separate set where of photomos that would turn on and to discharge the capacitor with the measuring side equipment. So the challenge here in using this design is you need to have very good isolation between input and output, and our photomos is able to achieve the really high isolation. It could do 5,000 volts between input and output, and also very high voltage isolation across the output terminals as well. And I also wanted to mention we do have other traditional types of solid state relays, which are triac driven or transistor driven. One example here is our AQAD, which has a transistor output. So it's designed for DC applications. So there's two variations. One is 30 amps at 100 volts DC, and the other is 10 amps at 600 volts DC. So this is built in with a varistor for excellent surge absorption, and has an internal diode that protects the element on the output for this particular DC type. And there also is an LED indication as well to allow the operator to see if it's currently functioning. Moving on to snap action switch type products away from relays. So we've seen a lot of these for various types of applications, particularly if you have any kind of lid that opens and closes. For example, in a cleaner, you may have a dust box that you would open and close. And so this switch would be used to detect that lid detection. But maybe more commonly for AGVs would be for bumper detection or for tire floating detection. So if you have making any contact with another object, whether it's on the floor or a wall, for example, it would engage the switch and let you know that that the robot has made contact. And so we offer both sealed and non-sealed variations of these switches. And these are extremely durable and have a long history of being used in the automotive space as well. We do have one specialty type, which is our ASQMR relay. And what's interesting about this one is it actually has internal resistors inside of the switch, and that allows you to actually diagnose any kind of failure mode from an open circuit versus a short circuit. So if you have a wire cut, for example, you'll actually get a different voltage output than you would if it was just a short circuit or an open circuit. We also offer custom wire harness solutions. So if you are using a micro switch in your design, I just want to point out that we do have the ability to mold and assemble different wire harnesses. And this is a custom solution, but we do have a factory in Mexico. So if you were to give us your bill of materials with all the components used for the wire harness, our factory in Mexico would procure all the components and assemble them together, and it would be one single part number for your design. And it makes things a lot easier when you have when you're only working with a single factory for multiple components, particularly if any quality issues arise. And then we could also help reduce the lead time as well, since everything is coming out of just one factory. Next, I want to move on to a solution that we have on the sensor side, and this is mainly for occupancy sensing, which we see a lot in autonomous robots for disinfection. So we do have infrared, passive infrared sensor devices, and some of the advantages for our passive infrared sensors is that we're able to get them extremely small in size. We're able, compared to our competitors out there, have a much better sensitivity as well. So it's able to detect much better performance compared to discrete type solutions. And everything is all inside of a one chip package ASIC. So it is a plug and play device. It's very simple to operate. It's very easy to design into a circuit and could save a lot of time than having to do it discretely. But basically the way that this sensor operates is it detects any change in infrared as a person would move from one detection zone to another. So it doesn't detect what direction the person is walking in, but it will detect if there is motion present. And we do have various lenses available as well. And these lenses dictate the field of view angle as well as the distance as well. So if you have a specific requirement for how far out you need to detect and how wide of a field of view you need, we might most likely have a lens. And we could also do some simulations as well, so you can see what lens detects what distance at what height, depending on what your setup is in your design. One thing that we do that I should say about this design is that um, these sensors are not meant to be used while the robot is moving. So normally, once the robot is in place where it needs to start detecting to see if there's motion, that's when the infrared would be useful in the application. And then there's one last product I want to go over, which is our connectors. So Panasonic has been making very extremely small size connectors for decades now. Actually, the largest pitch we offer is 0.5 millimeter between the pins, and we go as down to 0.3 millimeter pitch. And a lot of these are used in very ruggedized type of applications, such as even this cell phone type market. So they're extremely robust when it comes to shock and vibration. And our newest type of connector that we offer is our 5G connector, which I'll go into a little bit more in depth. And the purpose of this is for 5 millimeter wave antenna modules. So just to give you a little bit more background on our connectors, there are several features that make it very robust. The first is what we call double contact or V-notch construction. This means there's actually 2 points of contact where the socket and header touch each other, and the surface to edge contact also increases the contact pressure between the two pieces. Also, the V-notch gap between the two allows for any foreign matter such as flux or dust to fall in through that gap rather than clogging up your connection point. The second feature is the bellowed contact construction. Basically, we roll the metal surfaces rather than stamping it out from a metal plate. And this allows us to get the flexibility characteristics and to perform more like a spring, which it enables the connector contacts to absorb the shock and vibration in the direction that it needs to. Also, we employ a nickel barrier construction, and the purpose of this is to prevent solder from creeping up the terminal and getting inside the connector, which is really important for these small size connectors. And we also porosity treat the surface of these connectors as well. Even though the top layer is gold plating, because it is such thin layer of gold, there's a possibility of pinholes developing in corrosive environments. So this porosity treatment would fill it in with a conductive membrane and give it the same performance as though it had thick gold plating. And so I wanted to bring the attention back to the 5 millimeter wave 5G connector. And basically, this has really good signal integrity parameters by use of the metal shield insert molding in the connector, which helps isolate the high speed frequency signals. So if you do require high speed 5G type communication within your robot, we do have this feature. And then it also offers 5 additional standard signal pins as well. And again, this has extremely high removal force. It's very tough against shock and vibration. And we believe this to be the smallest sized 5G connector in the market with the best signal integrity parameters.
Thank you very much. Thank you, Jeff. Eric, if you don't mind, you are next, sir, with covering grid eye sensors.
Okay, thank you, Brian. Hi, everyone. I'm Eric Johnsrud, and I'm going to go over our infrared array sensor, Grid Eye. So Grid Eye is a passive thermal sensor, similar to the PIRs that Jeff just went over briefly, but there's a major difference between them. Our Grid Eye sensor is a always looking sensor, where the PIRs are looking for a detection event. What that means is that this sensor is constantly giving you data of what it's seeing so that you can use this for more types of detection. So the advantages of that is that this sensor is able to detect motionless objects, or even the direction that a moving object is going in a given space, so that you can do better tracking. These sensors are also useful for temperature measuring and thermal imaging. So these can be used for human detection, such as people tracking in a given space, or even gesture detection on an object. So the way that the grid eye works is that it has an 8x8 pixel array. So that's 64 different data points that it's constantly streaming out. From those data points, you can then use software in order to identify what's going on in the given space. There is a ASIC inside this sensor that allows for some processing, but a lot of it has to be done externally. So here are the specifications for the grid eye. There are 4 major types: a high gain and a low gain type, with a 3.3 volt drive and a 5 volt drive. Currently, we have a 60 or 36.5 degrees lens, and we have a 90-degree lens that should be coming out shortly. For the high gain, it's a better accuracy, but a tighter temperature range that it can see. So the accuracy is about 2.5 degrees C for the outer pixels, with plus or minus 1 degree C on the inner pixels, with the low gain being plus or minus 3 degrees C on the outer pixels, with plus or minus 2 degrees C on the inner pixels. There's also, so the detection range for them is 0 to 80 for the high gain and minus 20 to 100 degrees C for the low gain. These sensors all communicate via I²C, and they have a selectable frame rate of 1 frame per second or 10 frames per second, depending on what you're detecting. So this is going to show some of the software that we have available. We have various amounts of software that can be provided to you with a software license agreement, which is at no cost to you, but as long as you're buying the sensor. So this is one of the human detection software. So this is showing the sensor in the upper left with the raw image. We then interpolate that up in order to get a better viewing area. Then we take a background image from the area. And then through differentials, we are able to see what is going on and what is changing in the environment. From that, we identify, apply some logic to detect what those are, to then track the existence of a person. So while the sensor won't be very good on a moving object, this can be used in the given area to identify what's going on and being able to kind of tell the robots what's going on in a given space. So you can see as the people start to come into this room, they'll quickly be able to identify that a change is happening and start to identify a person, and then output that there is somebody in that given space. This sensor ideally works looking at a given space that's not moving, because it needs to have that differential image in order to calculate the person in a given space. So this sensor is very useful for controlling a given area to identify what's going on in that space, as well as being able to identify who's going where, so that you can have an area that where your robots are that needs to be controlled with people, so that when you know that somebody's in there, you have the robots on more concern, but once those people leave, the robots can go back up to the full speed. So this is just showing again that this sensor can be identified someone going into an area, and then also identify that they are leaving a given space by identifying the direction of travel each way. Okay, thank you very much. That's what I've got for grid eye.
Thank you very much, Eric. Nice job. We are going to go next with Mr. Jerry Machado. Jerry's going to cover film caps, inductors, and hybrid caps. Jerry, whenever you're ready, please.
Hi, I'm Jerry Machado. I'm the new business development manager for Panasonic's passive components, and today I'll be presenting a little bit about our film capacitors, inductors, and hybrid capacitors for autonomous vehicles. We'll begin with a quick presentation of our film capacitors. They're outstanding for DC-DC and AC-DC converter applications in a variety of autonomous and electrically powered vehicles. As we all know, electrically powered vehicles are becoming more and more dominant out there in the marketplace today for a variety of reasons, including environmental and safety and requirements for larger batteries and capacities. Our film capacitors are ideally positioned to accommodate these issues. They're fully compliant with AEC Q200. They provide a high level of safety with our segmented metallization technology, which I'll be going into a little bit later. We can support a high level of ripple current, and we're optimized to exist in high humidity, high heat environments. And this is all a function of a couple things. Our vapor deposition capability. We have ability to put down patterns with an interesting fuse option, heavy edge deposition capability to accommodate higher currents, and we've developed a unique potting resin that allows us to operate in the high humidity, high temperature environments. And if you look at the slide on the lower right-hand side, you'll see kind of an overview of the capacitors as they exist with the metallization and the dielectric film. And the interesting part is that in the fuse pattern on the lower right-hand side, you can see that if you have a fault in the dielectric where you have a short circuit, the current will burn those fuses out, thus eliminating that segment from the capacitor, lowering the capacitance a tiny bit, but giving you overall same capacitance at the same voltage, giving you a longer lifetime in specific applications. And you find these capacitors on a wide variety of applications in the charger world, both onboard as well as wall chargers. And you can see block diagrams of several different chargers here in this slide. And at the top, there are a number of numbers in there, and that's where you would find our different capacitors. We have input capacitors, which are safety capacitors for AC-DC converters, like number 1 in the wall box charging application. And you can see that you need, the safety capacitors in a variety, all of the applications, as well as the filtering applications, the DC link applications, and the output filtering applications. Moving on to our power chip coils, our PCC inductors. This is an interesting inductor. It's different from a standard ferrite inductor that's wound. These inductors the windings are encased in a metal composite that locks them into place and gives them a number of characteristics that you wouldn't find in a standard inductor. And you can see these on the DC bias characteristics where you have inductance plotted as a function of current. And standard inductors saturate. That's the way inductors work. Ours saturate as well, but at much lower rate. We call this soft saturation. So the inductance remains somewhat the same over current. And if you look at impedance as a function of frequency, our metal composite inductors change much slower in the standard ferrite type. The windings themselves are encased in this metal composite matrix that holds them in place. So the inductors will not hum at any kind of frequency, and that is aesthetically pleasing in a lot of applications. And finally, thermal conductivity characteristics of our metal composite inductors are superior to what you would find in a standard ferrite type. And if you look at our inductors compared to several other inductors like from Vishay and for TDK, you'll see that our metal composite is similar to Vishay's, but we have capabilities of higher voltage, and TDK's, their ferrite inductors are somewhat different, again, from our metal composites. So we have the soft saturation capability. We can accommodate more current through our soft saturation, and our temperature characteristics are somewhat better. And oftentimes it's difficult to have a second source for inductors, but our metal composite inductors can replace very easily the Vishay LP or LC series of inductors. And you can see the footprints shown here going from 5.5 up to 10 by 10 for the Vishay inductors, the LP series, and for the TDK inductors from 6.6 to 7.7 by 7. Moving on to hybrid capacitors. Hybrid capacitors are interesting capacitors. It combines the best of both worlds of electrolytic with polymer capacitors. You get, with electrolytic capacitors, you get high reliability from the electrolyte. You get the advantages of high voltage, high temperature, low leakage current, and you combine that with the polymer electrolyte where you get a large current, low ESR, small size, and higher conductivity. And the hybrid capacitors themselves are all AEC-Q 200 compliant and can be used in a wide variety of electric vehicles and autonomous vehicles out there. The capacitor itself, as I mentioned before, combines the electrolyte of both the polymer and the electrolytic capacitor. And you can see that you get really excellent electrical conductivity. The conductive polymer is about 10,000 times more conductive than the electrolyte, and the electrolyte gives you the high voltage characteristics. So you get low ESR, low current, high reliability, long life, high voltage, and large capacitance. And I should mention temperatures up to 125 degrees C.
Thank you very much, Jerry. We will move next to Mr. Matt Rose. Matt Rose is going to cover our wireless options. Matt, whenever you're ready.
Hi, I'm Matt Rose, and I'm the product engineer for our Wi-Fi and Bluetooth portfolio at Panasonic. Today I'm going to be covering the PAN 1781 wireless module. It's based on Nordic's NRF52820 device. And this is a promo board we put together called the Gatekeeper with one of our distributor partners, Future Electronics, and it's a very fun product. I'm going to talk about Bluetooth low energy, different versions. So we are familiar with classic Bluetooth. Those are versions 1 to 3. BLE came out in 2010, and that's versions 4 to 5.3. Now 5.3 is the latest version to come out, and I'll talk a little bit about that. That covers advertising and connection enhancements. Now this slide here shows a more graphical approach to the 4 different use cases for BLE. You have data transfer, which is probably 90% of our customers use that mode. That's point-to-point communication, transferring data. You have device networks or mesh networking, location services, which is angle of arrival and angle of departure. In the future, we should see high accuracy distance measurement, and that's range measurements down to 10 to 15 centimeters. And then the 4th use case is audio streaming, and we should see the specification for BLE audio coming out this summer. A lot of the focus for autonomous vehicles has to do with long distance communication. So in BLE, you do have a long distance mode where you can get out to 1,200, 1,500 feet of range. So you could conceivably control say a garden maintenance robot or a lawn mowing robot with your phone. Did mention the 5.3 enhancements, and this is mainly for battery operated type of applications. You have periodic advertising and enhancement mode, channel classification enhancement mode, and the connection subrating. Back to our module, the 1781. So this is a 15 by 8 millimeter device, includes Bluetooth 5.2, and is based on Nordic's NRF52820 device. Now it can be used in high speed and long range. It can be used in BLE mesh, angle of arrival, transmit capability, and has some rudimentary audio capabilities. So we put together a promo board with Future that focuses on that BLE long range capability, as well as some other Panasonic devices. Here's a picture of the board with a CR2477 coin cell for size. And the 3 different modes that you can use the board in is baud rate versus range calculator. There's a PIR sensor for occupancy detection, a relay, a buzzer, and a switch. Really quickly, the PIR that we used was the EKMB 1308-111K for occupancy detection. The relay was the TX25V. This is to open and close a gate. The switch, so somebody at the door can show you that they're there, and then battery for battery operations. Did create both Android and Apple apps for this device, and I'll talk a little bit about those apps here in a second. When you open up the app, the first thing you do is scan for the device. You see it's Panasonic 42, and then you connect with the device. Here we show the PIR operation, so you can wave your hand in front of the PIR and it blinks. There's an LED also indication for blinking, so this would be to show somebody is at the door. And then we have the relay or latch, and this way you can control the opening and closing of the gate or the door. And then there's also a little doorbell buzzer, and it can also create a buzz on your app. And you hear Sam the dog going arf when he hears the doorbell ring. We have different modes for the range baud rate testing. So this is the close range testing, and you can use the Galaxy S10 or Android 11 type of devices for this. Also use the iPhone mainly for close range because we don't have access to long range mode in Apple phones just yet. So different testing, this is at 20 feet. So the different modes, standard mode, 1 megabit per second radio, high speed radio, 2 megabit per second, and the long range radio. So we see in the standard, we get 32 kilobits per second. In the high speed mode, we get 72 kilobits per second. And in the long range mode, we get 3.57 kilobits per second. So that's just a look at the different modes at one range, 20 feet. We can do different long range testing. 30, 40, and 50 feet was what I tested. You can see a picture of my house there last fall. In the long range mode with the Android device, we got 3.57 kilobits per second at 30 feet, up to 50 feet, around 2.5 kilobits per second. And you can go out to hundreds of feet, and that baud rate will stay probably down into the bits per second. That's my presentation. Thank you.
Thank you very much, Matt. And after Matt, we're going to go into time of flight cameras with Nick DiGaetano.
Thank you. Good day, everyone. My name is Nick DiGaetano. I'm with the Panasonic Strategic Marketing Group. Today, I will briefly go over our new time of flight sensor camera. For those who are not familiar with the time of flight technology, it's pretty simple. A TOF sensor camera uses infrared light to determine depth information, a bit like a bat sensing its surroundings. The sensor emits a light signal, which hits the subject and returns to the sensor. The time it takes to bounce back is then measured and provides depth mapping capabilities. This provides a huge advantage over other technologies as it accurately measures distances with a single laser light pulse. Next. Whether an image is color or infrared, it's quite difficult to determine how far the objects are, especially if the field of view changes are shown on the bottom left image. Using the time of flight principle, a depth image is created, and simply by correlating distance with color, one can quickly see how close or far away the objects are. The reddish being the closest distance, and the dark blue being the farthest distance. Next. We have two different time of flight sensing camera modules, one for indoor use and one for outdoor use. The major differences are, with the indoor model, the camera can provide infrared imaging data, depth imaging data, and also color imaging data. This is useful to detect objects, how close, how far away they are, and if needed, a color image for visual identification. The outdoor model, even though it does not have the color option, has more electronic filtering for outdoor infrared interference. This allows crispier images under sunlight conditions. Next. These are the two models that we just mentioned. On the left side, we have the indoor model, which is the GC1, and on the right-hand side, we have the HCW4, the outdoor model. Both are quite small in size, 2.5 inches by 4 inches by 1 inch. Next. We do have other models shown here. Basic differences include the field of view of 55 and 90 degrees, depth pixels of VGA and QVGA, 24 and 30 frames per second refresh rates. It draws about 1 amp and 250 milliamps in standby mode. And it has two class 1 laser diodes on each side of the front of the camera. The common interface protocol used is I2C. You can also attach an Ethernet card behind it. Next. The infrared light sources originate from the left and right-hand side windows shown here. Each has a pair of 2 laser diodes, 855 and 940 nanometers in wavelength for indoor-outdoor use respectively. Also shown is where an interface card is mounted. We provide 4 mounting holes, 1 each corner for easy installation. Next, our time of flight sensor consists of 2 boards. One is the camera board and the other is the motherboard. The camera board handles the emission and reception of the infrared light and the processing of the image data, while the motherboard manages the interfacing and signaling of the output data. Next. Here we are showing an actual output of the camera. This happens to be an outdoor model. You will note how crispier our depth image is compared to the actual color image versus the others. An interesting thing to note with infrared light that certain black dyes absorb infrared radiation more than white or transparent materials. This is because black is absence of colors and white is a mix of all 7 colors in the white light spectrum. When an object appears to be in a certain color, say red, for instance, it means that the object is reflecting the wavelength of red light, 620 to 750 nanometers, and absorbing the wavelengths of all other colors. In the case shown above, the metal plate on the floor is challenging to detect. We tend to do a better job on sensing it. Next. Here we are showing some success designs in the past using your time-of-flight camera. Next. In general, this technology has been used in business, academia, healthcare, retail, milking industry, people tracking, and also smart video conferencing. Next, in fact, at the recent 2021 Olympics, for example, our time-of-flight camera was showcased in the Toyota's humanoid Q, where the 6-foot, 10-inch tall robot wowed spectators that has scored a free throw, a three-pointer, and where sunk over 2,000 free throws in a row. Finally, next, this is how it shows our camera, how small it is. And this ends my presentation. If there are any questions, please let us know it as soon as possible. Thank you. Thank you so much.
So thank you very much for your time, everybody. We really certainly enjoy you taking the time to meet with our team to go over the agenda attached. Just to recap very quickly, Jeff Katz went over our relays, including photomos relays, including our harnesses, some of our connectors, along with our switches and our PIR sensors. And then after that, you heard Eric Jondred go over the grid eye sensor. And then Jerry went over our passives, including film caps, inductors, and hybrid capacitors. And then you heard Matt go over our RF solutions, including the PAN 1781. And then Nick went over our time-of-flight cameras. We're going to go ahead and move into the Q&A session if you'd like, but I certainly just want to remind you that if you would like some more in-depth conversations with our product personnel or our business development managers, please leverage the Mel Foster team. Mel Foster is your main point of contact. And what they could do is they could set up either a quick conversation or a more in-depth review to discuss any of the topics that you heard today. So again, thank you very much for your time, and we appreciate you joining us today.